All right, let's go through an online inference example with Kubetorch. So last time we used the general capability of Kubetorch to take an arbitrary Python function or class and deploy them to cloud compute in Kubernetes to do training. So that's offline. I'm basically just taking my training function, I'm deploying it to distributed GPUs, and then calling it within my offline workload, which maybe then I schedule from CI or from Airflow or something like that. For online workloads like inference, you can use the same API. It's a service in Kubernetes. It can handle inference if your function or your class is an inference function. But we also support this cute decorator-based API, which is pretty convenient for building certain types of composite inference applications, which I'll show you in a second. So here I'm deploying Llama 3 8B instruct with vLLM. If I weren't using Kubetorch, I would have two options. I could basically either deploy the vLLM Docker image as is, and then I have to wrap it in a deployment and a service and handle the auto scaling and all this and how I handle failures and retries and things like that. And then if I actually want to call it, I need to create a jump machine to be able to proxy my requests to the service in Kubernetes. And then if I wanted to have any kind of pre or post processing or prompt validation or even use a custom prompt inside the application, all that needs to go outside of the vLLM image because I'm not modifying the vLLM image. So I need to publish another application in Kubernetes, let's say like a fast API app that handles all that pre and post stuff. Or I can use the vLLM Python API and in my own fast API app, so that's where I'm doing the pre and post or any kind of validation. I'm just calling vLLM inside that app. But then that fast API app needs to run on a GPU, and I actually need to pay attention to GPU utilization. And if I'm chaining multiple different calls together, in particular, I need to make sure that I'm not bottlenecked anywhere in those calls. And in addition to that, I'm doing all the same stuff. I'm doing the deployment, the service, the auto scaling, all of that on my own. With Kubetorch, I don't really need to worry about any of this. I don't have to worry about whether I can call it or how to get the application working, even though I can't run vLLM on my laptop. It's all taken care of for me. So here I have a class that represents my inference. It's using completely standard vLLM stuff that this is kind of hello world level vLLM. It's just loading the service here inside of the init method of the class, which is going to load up as soon as I deploy the class. And then I have this generate method, which takes in queries from users and then passes them into the vLLM server and returns the outputs. So this is really dead simple, but if I deploy this to Kubernetes, it's going to be an extremely performant Llama inference application. So with the Kubetorch decorator API, I just specify the compute that I want this to run on, just as I did with the .2 API. And so I'm also just using a GPU like I did before. I could specify CPUs, memory, disk, etc., specific GPU types. Specifying the image that I want is a PyTorch image, and I'm also installing vLLM here with UV. vLLM recommends a certain amount of shared memory, and I also want to pass in my Hugging Face secret to be able to download the Llama model, and we have a nice API to be able to do this securely. We can also support arbitrary secrets you want to pass up into the pod with the same API. And so when I'm ready to actually deploy this, I just hop over into my terminal, and I use the Kubetorch CLI, KT deploy, on the file, and if there are multiple, that we basically just look through that file to find any functions or classes that are decorated this way, and we deploy them live to Kubernetes. So you can see this is getting deployed, and then we're also installing vLLM on the fly here into the image, and then my service is ready. And the service is a real Kubernetes service. It has an HTTP endpoint internal to the cluster, if I want to call it that way. But the convenient thing about this decorator API is I can also just import the class from anywhere and call it, and that will proxy to my service. So I don't need to worry about jump machines or port forwarding or anything like that. Truly anywhere I am, I can just call this llama.generate method, and it will proxy my request over to the cluster. So here, I'm just going to make this call, and you can see it immediately proxies over to my service. And let's say I have a friend who I want to share this service with. From anywhere, I can just start a Python interpreter, import that class, and then call the method, and it will proxy my request to the right place in Kubernetes. So this is outside the cluster, and it works exactly the same way if I'm inside the cluster, let's say in an app that I deployed in production. So I mentioned this is really convenient for composite applications. So let's say I had a RAG app, which this is a RAG app, a very simple RAG app I've written with as a fast API app. And I have a generate method, and let's say I need to call an embedding, and I also need to call, I need to generate some tokens with my Llama model. because I use the decorator API and I can just import and call that function or class from anywhere, my RAG app is like dead simple. I just basically need to wire up the vector DB, and then I have this embedder class is decorated similarly to my Llama class, and it's also auto-scaling, and it's just using a simple embedding. And so inside of my generate method, I just call that embedder, and it gets proxied to the right place. And then I do my lookup in my vector store, and then I just call my Llama service, and that will also get proxied to the right place. And really conveniently, if I'm running and testing this Fast API app locally, I can run this as is and test it locally as is, and those calls will get proxied up to the requests in Kubernetes. And if I'm iterating on any of the three of these, on the embedder or the Llama or the Fast API app, I have extremely fast iteration because I can redeploy any changes I want to make to the Llama app or the embedder app in seconds using KT deploy. And then when this is actually running in production, each of these services is running with its own auto scaling, and everything is getting called to the right place. So when I get a request, it's going to get passed into the embedder service, and then it's going to come back and it's going to get passed into the Llama service. And each of those is auto scaling, so I don't even need to think about optimizing the throughput through them or anything like that. Whereas if I bundled, let's say, the embedder model and the Llama model together inside of my Fast API app, I'd have to do a lot of profiling to make sure that there are no bottlenecks in this chain of executions. And if I auto scale my Fast API app, if I auto scale the RAG app itself, I don't really have to worry about how those calls are flowing to the embedder or Llama either. All my replicas of my RAG app of my Fast API app are getting called to, are getting proxied to the embedder and the Llama services automatically for me. So all of this just flows together, and the retries, the scaling, it's all taken care of for me. So that's basic online inference with Kubetorch. We're also going to publish some examples showing more high performance. vLLM is plenty high performance, but things like Triton we'll show soon. Yeah, thanks.